Yeah, thank you for our session chair. Wow, it's actually, I feel a little stressed, especially after two professor keynote speakers presentation, especially Professor Brilakis and also our online keynote speaker, Dr. Mariana. Yeah, and good afternoon, everyone. This is Rennie, and today I'd like to share you with guys about my research topic, which is about a blockchain-based carbon auditing framework for construction material and product certification. Yeah. And first, I'd like to start with some background introduction and also some introduction about existing problems in the carbon certification schemes for construction materials and products. Yeah. First, let's take a look at the background. Yeah, I like to show the latest global report published by United Nations Environmental Programme in 2022. Yeah, from this figure, we can see that the building and construction industry actually represents around 37% of global operational energy and process-related carbon emissions. And this figure is actually very large. And let's take a detailed look at this figure. We can find that among the whole life cycle of a building, the manufacture of construction materials actually contributes around 30% of total carbon emissions in construction, which is the second largest carbon contributors. Yeah, of the building life cycle. Yeah, so that in this case, we can see that it is actually very important to carefully manage carbon footprints of construction materials and products so that we can better reduce the carbon footprints at the very beginning stage, yeah, such as the construction design stage. Yeah. Okay, so after that, we can see that currently, actually, we have different carbon certification schemes, and it has become a useful tool to manage carbon footprints for construction materials and products. For example, in UK, there is UK Carbon Trust for different products. And also in Singapore, it has sustainable product certifications, especially for building products. And also in Hong Kong, we have our green product certification, especially designed for construction materials and products. And take the Hong Kong's Green Product Certification Scheme as an example, we can see the whole workflow of this certification scheme, and also we can see the scope of this certification scheme is about from the life cycle view is around from A1 to A3 stages. And also it provides a carbon footprint calculation form. And also we can see from the website, we can finally find some construction material and product certificates issued on the website. And however, we can still see some problems existing in the existing such kind of carbon certification schemes. For example, the first problem is about there is limited transparency of carbon footprint data for construction material and products. Because in most kind of certification schemes, users can only get the total carbon footprint of the construction material and product via the results. However, it is hard to track the detailed carbon footprint of such kind of CMPs, especially there is higher and higher supervision requirements. So users cannot be able to track components' carbon footprints in the construction material and product. For example, the user cannot know which kind of cement used in the concrete. Yeah. And the last problem is about the security problems, especially under the centralized data management environment in traditional certification schemes. We can see some data tampering and manipulation phenomenon, especially there is an existing phenomenon about greenwashing. Yeah, some companies, they want to use falsify or even tamper with the certificates to find some green financials. Yeah, so in that case, it actually reduces the credibility of certification schemes. So based on these problems, this research aims to facilitate the whole transparency, reliability, and trackability of construction material and product carbon certification. Yeah, so that's we need blockchain. Yeah. Based on some characteristics provided by blockchain, we can realize the transparency, reliability, and the data trackability. And as we all know that blockchain applications has actually been exported in many construction scenarios. So however, in this field, it has not been well addressed. So the first sub-objective of this research is to develop a blockchain-based framework for CMP certification. And also there's one concern, and what is also the reason of why it is not have been well addressed using blockchain in this field. That's about the data leakage problem. So in this research, the second sub-objective is to protect carbon data privacy under the transparent blockchain environment. So for this part, based on these two sub-objectives, we try to propose our methodology. To realize the first sub-objective, we propose decentralized blockchain-based framework for construction material and product certification. And to realize the next sub-objective, here we propose that we want to protect carbon data privacy under the transparent blockchain environment. In this case, we propose our privacy-preserving carbon data sharing schemes. And finally, we want to realize the main objective of this research, which is to facilitate the transparency, reliability, and trackability of construction material and product carbon certification. Let's take a detailed look at this one. And for the first part, we propose a decentralized blockchain-based carbon auditing framework. And in this framework, we can see there are three kinds of stakeholders actually following the traditional workflow of carbon certification. And also we try to structure the data requirements based on different roles, which actually is designed with the traditional data requirements. In that way, we generate the basic unit of blockchain components. That's why we transfer the knowledge in the carbon certification to the blockchain unit, which is transaction. And also to protect the data privacy, we design some encryption schemes in this framework. For this part, our contribution is that we propose a customized and secure carbon data sharing mechanism for blockchain-based carbon auditing. And in the next part, and just as I mentioned before, the carbon data privacy actually is a problem when we try to implement blockchain technology in these certification schemes. So in this case, we propose a whole architecture which integrates the data privacy layer to protect such kind of carbon data privacy. And first, as a data access layer, we try to propose a 2 privacy level blockchain data model for carbon auditing during this certification. In this data model, we try to classify different carbon data with different privacy characteristics. And then as a data privacy layer, we try to integrate with asymmetric encryption to protect such kind of private carbon data. And here I want to share some results and also our development process. Here we prepare some tools and also softwares to develop such kind of prototype. We use Ethereum and also use the Ethereum testnet Goerli to do this development. And here I will use some illustrative scenario to show the final results. Here is the basic process map of this scenario, and which is about how to record the carbon footprints for the construction material and the product. And here I will briefly show some results to show its feasibility and functionality. Here we can see it's from the easy scan about the one engine to search the blockchain transactions. Here we can see the contract address, and it shows the framework can successfully distribute public keys to secure carbon data. And also we can see the whole information that's shared in this engine, and we can see the important data actually have been securely shared. And also, so in that way, we can see this kind of framework can facilitate the transparency, reliability, and trackability. And finally, it comes to the conclusion. And here I listed some conclusions. First, we propose a general framework with workflows for carbon auditing. And also we propose a two-level privacy blockchain data model. And also we integrate the asymmetric encryption to secure such kind of private carbon footprint data. And for some limitations and future work, and currently we only focus on the carbon auditing stage during the certification workflow. In the future, we want to extend to the whole process of certification. And also in the future, we want to test more scenarios and also do some more evaluation. Yeah, thank you all. That's all for my presentation. Thanks.